Is time an illusion? The mind-bending truth hidden in quantum entanglement. Get ready to challenge everything you think you know about time. That familiar ticking clock on the wall, the passage of days and nights, birthdays and calendars. What if it's all an illusion? What if time doesn't actually exist in the way we believe? A groundbreaking study has come to a startling conclusion. Time may not be a fundamental feature of the universe at all. Instead, it might be an emergent illusion arising from the strange, mysterious realm of quantum entanglement. This concept isn't science fiction. It's a serious idea emerging from the forefront of quantum physics, one that could completely transform our understanding of reality, the universe, and even our own place within it. Let's unravel this astonishing theory, step by step, and explore why time might be nothing more than a perception, not a physical reality. Compass, what is time, really? Time governs everything we do. It flows from the past into the present and stretches ahead into an unknown future. It structures our days, marks our milestones, and seems to march forward relentlessly. But what is it? Even defining time is difficult. Ask 10 people and you'll get 10 different answers. To most of us, it's just numbers on a clock or dates on a calendar. But in physics, time is far more elusive. Albert Einstein famously said, "For us physicists, the distinction between past, present, and future is only an illusion, albeit a persistent one." In classical physics, time is linear and irreversible. Everything, from the ticking of a clock to the expansion of the universe, seems to unfold along a single arrow, from past to future. But this simple concept hides deep mysteries. Brain time, objective reality, or human perception? Let's pause for a moment. Is time something physical, like space? Can it be touched, bent, or measured in absolute terms? Or is it just a mental framework we use to make sense of change? Most physicists define time as the sequence of events, the before and after, the cause and effect. It's what prevents everything from happening at once. As physicist John Wheeler once said, "Time is what keeps everything from happening all at once." But as we venture into the strange world of quantum mechanics, our everyday understanding of time starts to fall apart. Test tube classical physics versus quantum mechanics, a fundamental divide. To understand where the confusion begins, we need to look at the two pillars of modern physics. Einstein's theory of relativity. This explains how gravity and time work on a cosmic scale, stars, galaxies, black holes. Quantum mechanics. This describes the strange behavior of particles at the subatomic level. While both are supported by mountains of experimental evidence, they don't agree with each other, especially about time. In Einstein's universe, time is flexible. It stretches and compresses under the influence of gravity and velocity. Time slows down near a black hole and speeds up in deep space. It's woven into the very fabric of spacetime. But in the quantum world, time is strangely absent. Toolbox, enter Schrödinger's cat, a quantum paradox. Let's consider a thought experiment, Schrödinger's cat. In 1935, physicist Erwin Schrödinger imagined a cat inside a sealed box. A quantum event inside, like a decaying atom, could trigger the release of poison. Because the atom's decay is governed by quantum uncertainty, the cat is said to be both alive and dead until the box is opened and observed. This bizarre situation is called superposition, a system existing in multiple states at once until observed. Even stranger is the idea of quantum entanglement, where two particles become linked in such a way that measuring one instantly affects the other, no matter how far apart they are, even across galaxies. Einstein called it spooky action at a distance. He didn't like it, but it's real. It's been experimentally confirmed many times. Linked quantum entanglement, the link that changes everything. In quantum entanglement, particles don't have definite states until measured. Before that, they exist as probability waves, representing a spectrum of possible outcomes. When one is measured, the wave collapses into a specific state, and the other entangled particle instantly reflects this change, even if it's light years away. Here's the kicker. This interaction seems to occur outside of time. The change happens instantaneously, without any signal traveling between the particles. This directly violates the classical idea of locality, that things can only affect each other if they're close together, and only after some time has passed. So what does this mean for our concept of time itself? Puzzle piece, a new theory. Time as an emergent phenomenon. A recent study from the Italian National Research Council reintroduces a radical idea first proposed in 1983 by physicists Don Page and William Wouters, that time doesn't exist as a fundamental entity, but rather emerges from quantum entanglement. According to the Page-Wouters mechanism, time is not an external backdrop against which events unfold. Instead, it is a relational phenomenon, existing only in relation to the entanglement between systems. Think of it like this: an isolated quantum system that isn't entangled with anything else perceives no time. It experiences the universe as frozen, static, and timeless. But when a system becomes entangled with another, something fascinating happens. The interaction creates change. From the perspective of one system, the other evolves, and this evolution gives rise to a perception of time. Brain, a concrete experiment. Time without time? In the new study, scientists applied this theory to two model systems. A quantum harmonic oscillator. Think of it like a tiny particle vibrating back and forth. A system of quantum spins, acting as a kind of clock. The oscillator and the clock were entangled, and the entire system was described using the Schrödinger equation, but with no explicit reference to time. Yet, from the internal point of view of the oscillator, the clock seemed to tick forward. The system exhibited behavior consistent with classical time, even though time wasn't built into the equations at all. And when the scientists scaled up the model to simulate macroscopic objects, the illusion of time persisted. This suggests that the experience of time may result from entanglement, even at scales we're familiar with. Hourglass not done, what does this mean for us? If this is true, if time isn't fundamental but emergent, then much of what we take for granted about the universe may need to be rethought. The flow of time? Just a byproduct of entangled systems observing each other. The Big Bang and the start of time? Perhaps not the beginning at all, just the beginning of perceived change. Seconds, minutes, hours? Tools for measuring a relational illusion. According to physicist Sam Barron from the University of Melbourne, while physics abolishes time, it seems to leave causality intact, the sense in which one thing can cause another. So even if time as we know it doesn't exist, the universe might still be ruled by cause and effect, the true structure of reality. Rocket, where do we go from here? This theory remains controversial. Not everyone agrees. Many physicists argue that while it's mathematically elegant, we still don't know if it's physically meaningful. Can it be tested? Can it improve quantum theory or unify it with general relativity? Only time will tell, ironically enough. But one thing is certain. The deeper we peer into the quantum world, the more it seems that our intuitive understanding of reality is deeply flawed. Time, space, matter. These might all be emergent properties of something far more fundamental. Bell, final thoughts. Time is not what it seems. So the next time you glance at the clock, think twice. You may not be watching an objective measure of a physical quantity, but rather participating in a shared illusion born from entangled quantum processes. We live in a world where what we call now may be nothing more than a perspective, not a place on a timeline. And what lies beyond that illusion? That's a mystery still waiting to be unraveled. If you're fascinated by these mind-expanding ideas and want to keep exploring the edges of science and reality, subscribe so you never miss another journey into the unknown.